All right, folks, just a quick video to show you my AI sandbox that I created in Java. Now, the backbone of this, the neural network, I created by following this tutorial here. There's a link. I highly recommend if you're looking to understand how neural networks work under the hood. This is fantastic, and everything is from scratch. Ray is online is the name of the channel, and she does every line from scratch. It's fantastic. There are three chunks. So there's the neural network. I added the ability to serialize out that network, do some retraining of models. So once I've serialized a model, we can retrain the model, start at that point, and train it on new data if we want to. An FX app, and the FX app will allow us to create data. So the original series here, Ray did it on the minced data set, the hand-drawn digits. I wanted to do it on my own. I think that's how you pronounce it. I wanted to do it on my own data, so I created a tool so I could save out hand-drawn numbers as I created them, and then run inference tests against my model that I've saved. And then lastly, some tools to shape the data. And all of these tools exist, by the way. And the idea for me was I wanted to see how they all worked under the hood. So pretty much, well, everything here is from scratch. So tools to shape the data. And basically, I created 1,800 samples by hand. It gets kind of old, and I'll show you that. So I created some tools to augment the data. I was reading a blog from IBM, I think it was, and they were talking about the importance of synthetic data. I created tools that allow us to transpose, right? Shift the image a little bit, the number, rotate it, scale it, and blur it a little bit. So we get 4 times the data after we run it through these tools that we started with. So start with the 1,800 I created. You could add more, but then run these tools and you get 4 times the data. And then lastly, there's some tools in there to split it. So you want to split up your data training, and then you want to leave a chunk behind for validation, and then it's good to have a chunk for testing too. These tools here let you split it, and I'll show you how that works also. So I just got done training a model, and this is where I ended up. I ended up at 73% for that model. So let's just start by seeing it work, and then we'll go through each of the parts here. So we'll go to inference. There are 3 chunks. So you have the inference, and that's the FX app, the ability to shape the data, right, and create synthetic data, split it, and then the tools to train and refine the network, serialize out the network. All right, so let's run the inference first. I got a angry bulldog at my feet who wants me to play with him. Okay, cool. So we can put the prediction down here. Now, the only reason to put a value here is so it can keep a running tally as you go. So I'm just going to put a 0 because that's what I'm drawing. It'll predict either way. It's just telling you whether you're right or wrong. But you can visually see that I was wrong, right? So I created a whole bunch of 8s that way, and I'll show you that in a second. Let's try. Oops, that's not a great 0. But let's try and see. There we go. Now we're at a 0. Let's try a 1 here. And again, it'll tell you the prediction. This is just so it keeps the tally here. So we're doing a little bit better. How about a 2? Nice. Oh, that's not a great 3. But I drew a whole bunch that were that bad. So it's 5 and 3. You can see where it might mess those up a little bit. Again, we're not talking a heck of a lot of data here. Let's go with a 4. There we go. Nice. Now let's try a 5 maybe. I'm sure you're bored watching me do this, so let's try to end on a good note. And we're at 75%. And again, our model, if we come up here, the last model that I saved was 73. So we're doing pretty good. Okay, now the next part of this interface is how do we save this data? So I'm going to go through and then I'll speed this chunk up. I think right now we're at 1,800. when I'm done, we'll be at, this takes a second. When done, we'll be at, let's see here. Yep, so we're at 1800. When done, we'll be at 1900. And again, I promise I'll speed this way up. So in order to do that, you'll use the top part. And it has a 0 here to start. And you just start drawing zeros. You're going to draw 10 of each, 0 through 9. And keep hitting save, although it's a pain to come up here. It takes forever to hit save. So I set it up so you can just right click. All right.
Seat to hell, I get a preview. We live in a world gone mad, that's lost control. What doesn't kill us leaves a hole in our soul. Chase the satellite, get lost in outer space. We're only human, we're flesh and bone, fighting wars within. We're only human, we're flesh and bone. Skeletons.
Cool. Okay, so now we're done. You could go and draw another set, but usually you don't want to go more than one round. So we created 100 values, and so we can let's kill this now. And if we come down here now, you can see we're up to 1900. So that's cool. So what are we going to do with the data now? Now what we can do is we can create this data. So let me delete this, get rid of that, and now we can use the second set of tools, which are the shape tools. And you can do one of two things. Well, you can do both things. You can choose just one if you want. But what it'll do is whatever file you have here, it's going to read, and it's going to turn it into augmented data, and then it's going to split it. In this case, I'm going to do an 80-20 split, so I have training and validation data, and it'll also shuffle it too. So it doesn't, as it's training, it doesn't train a whole bunch of 5s at once, right? It's going to kind of shuffle all the data. All right. Oops, I forgot to change it to. Here. Let me kill that. Change it to shape here. All right, let's run that. Folks, there's no error handling here. This wasn't set up so you could, build it into an actual actual application. That would take a little bit of work, but it's a handy tool to do some learning if that's what you want to do. So here's the augmented data. This would be about exactly four times bigger than our original data. And then this will have 20%, sorry about that, of this data, and then the test will have 20%, and then the train will have 80%. You could then split this in half if you wanted to, right? So grab that and split that at 50%, and now you could put half aside for testing and half for validation as you're going through. Okay. So that's that. And then the last thing you would need to do is actually train this thing. So in order to train it, you'll go to your train network. And there are 3 things you can do: train and serialize. You could fine tune. So this would just start with a model that you had already created, and you could then train that with new data. So you're starting with the weights and biases that you already had, which is great. And then you could do a test. So if you put some portion of your data aside, you could then run that against your test data. Okay, so let's just look at this part. We won't need to cover this. You can look at that yourself. We've got our 2 files up here. We're going to load them up, and drill into all of this if you want to see how it's all happening. And I hadn't used IntelliJ for probably about 5 or 6 years, more than that actually. It was a pretty good tool then, but it's fantastic now. One of the big things you'll want to play with is your learning rates, and you'll notice here I had a learning rate for my convolution layer and my fully connected layer as 0.1, And after 63 epochs, I got 69%. When I changed to 1, 5, and 2, I was up at 73%. Now, folks, a normal learning rate is probably going to be somewhere around here. This is just how fast we're making changes as we do our back propagation. So you can play with these. These values are a little bit high, but we've got a small data set. If you want to do some tests on learning rate instead of just kind of shooting in the dark, I have some code down here where you can actually fine tune it. And all this does is it puts oh no, it's down here. I'm sorry. This is to fine tune your model. This is to fine tune your weights. What this does is it puts a wrapper around the around your training, and then every iteration of the training, it runs another iteration and changes the rates. So you could step through that if you wanted to. Here we just do a single loop, right? So here's the loop for our training, and again, that would have this one would have a loop around this, right? Okay, so we're set up for 100 epochs. It doesn't really matter what you put here, because what it will do is it'll stop early if it needs to. So I added the ability to stop early. You don't want to get to as good as it's going to get at 50 epochs and then have it keep running. So it'll stop early if it needs to. So it just does a training run. And that'll do your forward and backward propagation on your data, and then it'll do a test. It'll do some outputting for you, and that's what's happening here. All right, so that's what's happening after each epoch. It'll print that out for you, and then it'll do another. Now it also saves this checkpoint every single epoch. So as it goes through, every epoch gets saved, and then in the end, it does this. I just added the checkpoint in case it crashed or something, or if I just wanted to stop it. That was before I had the early checking, but if I just want to stop it at some point and not wait for the early stop or for it to totally finish, I would then still have a model, right? Whatever the last full epoch that ran, I would have that checkpoint. So that's why I have that. Folks, the serializing is just Java serialization. So if you go to the model and go to the network, go to the actual network here, and again, I would watch Ray's stuff if you really want to know this. You'll notice that this is serializable, and that's how I'm able to serialize that network. I started by just serializing out the weights and biases as an ASCII file, and then I'm like, well, that's kind of a pain, and then I serialized out the layers, and I'm like, well, why bother that? Just serialize out the entire network, which is, in fact, a collection of our layers, and that's what we're looking at when we serialize this out. I think so. That should be it. I think that'll give you an idea of all the pieces. You won't have any trouble, using this. If you're going to fine tune it, you might be fine tuning it on a different data set. So this might be a different data set, and you load up a model. So you just load a model here. I'm just loading the checkpoint model, but you could change that to whatever you want. And then the same thing. This is going to have a checkpoint, so a fine tune checkpoint. And this goes through and basically does the same thing. The only difference here is, I could have combined these into one, but again, the idea was to have kind of a sandbox. So a lot of this is pretty verbose, as I am being right now.